And tonight we think about the people here in French Guiana who have been touched by this virus, and we want to tell them Chamberet Pamoli in Creole, you know Katie perfectly. So keep up, don't give up, keep up with all the measures. We need them, and we are convinced that today the Ariane launcher will bring all its power to French Guyanese people.
Luce, thank you very, very much indeed for joining us, and best wishes now for the rest of the launch. Stéphane, you're going to be coming back to us again later, but yes, for now, thank you very much.
You. Thanks so much.
Stéphane Israel, ladies and gentlemen. Well, I promised you some experts, and we also have Damien Gilles with us tonight. Damien Gilles is the head of systems engineering. Damien, very briefly, what does that mean?
I'm leading a short team of experienced system engineers who are in charge of mission conception for all the launch of Arianespace family, and mission design mainly covers trajectory and ballistic phase optimization, as well as demonstrations that the spacecraft can sustain the condition of a launch.
Great. Well, thank you very much indeed for joining us. Let's take a seat. And Damien's going to be with us now for pretty well the rest of the program. We have been preparing the satellites and the launcher for the last 3 months or so. It's called the launch campaign, started with the assembling the launcher. What happened next?
Galaxy 30 and MEV2 landed at Cayenne Airport end of June. They were transferred then to the payload preparation facility 72 kilometers away. They started there their standalone activities. In parallel, our lower passenger BSat 4B arrived in Cayenne and followed the same path until the same building, which is S5C, where it also started its standalone activity. You can see there on the images the feed check. Feed check is the operation where we check that we can attach the spacecraft to its nearby structure without any anomaly. After that, the 2 upper passengers were transferred to the hazardous payload processing facility, where they will be filled with propellant. You can see there people wearing specific suits because of the dangerousness of the activity. In parallel, BSat 4B was also filled with propellant in another building called S4. After filling, the next operation is what we call flight mating. It means that we attach the spacecraft onto its adapter. After flight mating, we can transfer the spacecraft from the payload processing facility to the building where it will meet the launcher upper part structures. For that, we use the dedicated container. MEV2 was hoisted on top of the Silda mid-July. As you know, the particularity of the mission is that we have 2 upper passengers. So Galaxy 30 followed the same path as MEV2 before being integrated on top. It started with the flight mating of BSat 4B onto its adapter, and then we have to transfer BSat 4B onto the BAF building where it will meet the launcher. You can see there the hoisting operation of BSat 4B onto the launcher. On that picture, you can also see the new vehicle equipment bay, which is a new item which will fly for this mission, and BSat 4B was mated on that. Once both parts were prepared, we can make the integration of the composite onto the launcher. Now the upper part is complete.
Well, thanks for talking us through that. Now, as we well know, there are lots of things we can control on a rocket launch, and they're a very, very controlled environment. But there's one thing we can't control, and that's Mother Nature. So we have a couple of weather checks, one at 20 minutes to launch and one at 10 minutes to launch. Let's go over now to Bruno Gérard, who we saw earlier in the Mission Control Center next to Luce. And Bruno, can you hear me? Great. Bruno can hear me, I think. Bruno.
Hello, Katie. I hear you.
Great. We've had the latest 20-minute weather check, haven't we, Bruno? What's the situation?
So situation is not bad. We got the information, so we have some clouds above us, but it seems okay on the lightning's problem. Winds are correct. So for the moment, up to now, we seem to have a green. This green will be confirmed at minus 10 minutes.
And Bruno, what's the weather like at the moment in French Guiana? I believe we're coming out of the raining season, is that right?
Yes, absolutely, Cathy. We just are going outside of the rainy season and we are entering the dry season. So the weather is quite changing, evolving, but up to now, it seems very good for this evening.
Bruno, what kind of conditions could actually delay a launch?
In fact, we have many factors. First one, of course, the winds, low altitude winds, high altitude winds, but also we have, like any airplane, the conditions about lightnings. We don't like to enter big storms, so we check all the weather above the launch pad, but remember that in 2 minutes we are outside of the atmosphere.
Great. Well, thank you very much indeed, Bruno. We'll await the weather check at 10 minutes too, but for the moment, best wishes for the rest of the countdown. Thank you, Bruno. So we are flying on board Ariane 5, as we've said, the big, powerful beast of a launcher, the heavy lifter of the Ariane family. We have 3 launches that we launch here. She's going to take off in just under She's going to take just under an hour to deliver our satellites. And so let's just have a look now at what's going to happen once she lifts off and how she's going to do that.
The booster ignition will trigger the liftoff of the launch vehicle. Shortly after the liftoff, the launcher will perform a pitch maneuver in order to get in the right direction. The booster separation will occur slightly more than 2 minutes after liftoff. Just after, we will separate the fairing as well. The main engine switches off when the intermediate orbit is reached. This event is called injection into orbit. Just after, the main stage is separated and will fall down into the Atlantic Ocean. The upper stage is ignited and it will carry our passengers up to the geostationary transfer orbit. During that flight, we have still the effect of the atmosphere, even if thin, because we fly very fast. This is the aerothermal flux. Upper stage switches off when we have reached the orbit. This is the beginning of the ballistic phase when we can separate all the spacecraft. First of all, Galaxy 30, then MEV2 separation. Before separating the BSat 4B, we separate the Silda. And finally, BSat 4B, our last passenger. The launch vehicle mission is not completed yet because it will start the passivation. After that moment, the Mission Control Center team will take over and the spacecraft team will make all the job to get the satellite up to their final journey.
Indeed, and of course, Galaxy 30 and BSat 4B will travel on their own to their final destination, which they have their own slot in space and they'll be going to that slot. But MEV2 is different, isn't it?
Completely different, because it will dock to another satellite, which is a customer of MEV2 to extend its lifetime.
So it's actually going to dock with another satellite, and then it's going to push it a little bit, use its own thrusters, and raise its orbit.
All the maneuvers, yeah.
Yeah, it's really, really exciting technology. Now we have 2 control centres working on the launch over in French Guiana. We've got the Mission Control Centre, which we've been looking at, but we also have another one. It's called Launch Control, and it's closer to the pad. It's about, I think, about 3 kilometres away. There it is. It's actually a concrete blockhouse, isn't it, Damien?
Yes, it is, and it is completely airtight at the end of the chronology in order to protect the people. We have there basically 2 teams, one which is the operational team who is responsible for the final operation before liftoff, and another one with the flight worthiness team who is in charge of checking the flight worthiness and last status of the launcher. This latest team is led by Guillaume Galato, the LSTO, whereas the operational team was led by the LCOM, Patrick Lucet, that we have seen at the beginning of the movie. And you can see there people working inside the CDL.
So that's the Launch Control Center there in French Guiana, but there is actually another one in France, in Europe, and it's called Space Code. It's an exact replica, so all the launch controllers in Europe can see exactly what the launch controllers can see in French Guiana. Let's find out a little bit more now about how it works and the reasons for it.
Welcome to all of you in our Space Code room in Les Mureaux, close to Paris. This is one of the rooms which is in place for each of our Ariane 5 launches, where we have operators preparing the launch during the day of the countdown, as it is the case today. When we prepare a launch, as we are doing now, we have in fact two teams which are working together. There is one team which is fully in Guyana, in the range of 50 to 60 people, who are actually operating the ground system equipment that work with the launcher, that feed the launcher with electricity, that feed the launcher with fuel, with propellant, and so on. And these are the people that activate equipment on board of the launcher. And there is a second team which is in place, and this second team is in charge of supervising the status of the launcher. This second team is in charge of checking each and every parameter on board of the launcher during the operations conducted by the other team. This second team, in fact, is divided in two parts. There is one part of that team which is now in Guyana, and a second part which is here in Les Mureaux. The first half of the team and the second half of the team are working together on the same displays. They have exactly the same setup of displays to monitor the launch. The difference between the two teams is that the people who are staying in Kourou for supervising the launcher from them, in fact, these people have more frequently a need to interact with the people operating the launcher, so the supervisors talking to the operators of the launcher. Here in Les Mureaux, the people who are here with us today are more looking at parameters of the launchers that will not require a direct intervention by the operators, but that may require a work together with a third team, which is a team of experts that are put at their disposal in another room in the Calm, and these experts will be called by the supervision team here in Les Mureaux, should there be, at any point in time in the chronology, should there be an anomaly, a singularity, something which has to be checked by technical specialists.
So hello everybody, I'm very pleased to be here with you in Les Mureaux premises. We are in a room where all the launcher technical leader will be for the chronology. We are in charge here to prepare the chronology in the Space Code rooms, so meaning with the preparation of an organization note where we gather all the people, the key people who are involved in this chronology. So, and during the chronology, we have also to ensure that all people are well positioned, and we have to ensure that all the communication with Kourou are correct. In case of a specific technical event or anomaly, of course, in the position of LSTM here in Les Mureaux, we have to alert everybody so that we can then work together and, of course, provide support to our colleagues who are also in Kourou dealing with this technical event.
Interesting, huh?
Completely, yes.
Two complete replicas. So the final countdown started about 11 hours ago. We're now 8 minutes and 37 seconds to launch, getting towards the end of that final countdown. What's been happening?
The teams have been completed the operation since this morning. Mainly the operation were checking the electrical connection between the different elements, flushing and cooling the feeding lines so that we can fill the tanks with propellant, activating the equipment on board the launcher, one after the other, to check the status. And we are doing this in order to be able to check that everything is working perfectly before we enter the synchronized sequence.
And here we can see the teams in French Guiana, the program director's desk. What are these guys doing? And there's the Jean-Christophe Delaunay, who is the
mission director.
And we can see here the status panels, and this is the range operations manager.
Yes. The range operation manager is the one that is coordinating all the activities on the basis and which receives all the information from different elements.
And he's the one who's going to be calling out all the important milestones because, of course, there are lots of buildings across the base. Yes. And everybody has to listen to the range operations manager to get confirmations of the main events. He's about to call one out now.
Attention pour la séquence finale lanceur.
So he has announced the beginning of the synchronized sequence. It's the last 7 minutes in the countdown. And this is the time now when really the computers are starting to take on the job, aren't they, Damien? What's happening?
The synchronized sequence is a sequence which is fully automatized, which performs the latest preparation operation of the launcher and of the ground, and the launcher is taken progressively autonomous, independent from the ground.
We can see in the Mission Control Center those boards that you're looking at on the left-hand side, the green panels. We call those the status panels, and all the systems across the base are sending their status there.
Yes, we have a panel which is made of all elements that are green up to now. These elements correspond to subsystems which send their status. So mainly we need the launcher, which will send its status. We need a go also from the customers, which will send their status. And finally, the launch base. Everything is like a traffic light. If it's green, it's a go. If it's red, we have to stop, investigate.
Exactly, or it's a little bit like the dashboard of a car, same thing. Now, we are now joined by Raphael Chevrier as well, who has come to see us here in the studio. Raphael, thank you very much indeed for being with us. You tell us your job and what you do, Raphael, for Arianespace.
Basically, I'm a business developer. So with my colleagues, we are working on new innovative mission concepts that we can address with our next generation of launch vehicle, Ariane 6 and Vega C, in the context of a very fast-changing satellite market.
And it is changing extremely fast, isn't it? Because, of course, everybody's, well, certainly, I think probably in March I had never heard of Zoom, and now I use the word like Google. Let's Google something and we Zoom it in English. I don't know whether in French you do the same thing. So things are changing. We all want more internet.
Yeah, there is Zoom, there is WebEx, so there is a real big demand in this dramatic situation of connectivity for situations of remote working. And so we know, and it confirms that the satellite have a role to play in this communication, providing through large projects of constellations, internet signals in order to connect everybody anywhere.
And right now we've got some very important satellites up there inside the fairing, which are going to help us to do that and make those connections. What are the conditions like inside the fairing? I'm guessing that they're kind of like first class in an aeroplane,
yes, we can
air conditioning and that sort of thing.
The fairing here protects the satellite from the outside environment, we can say. First, we monitor the temperature inside the cavity, and we also check the conditions in terms of humidity and cleanliness for it to be perfect before liftoff.
So right now they've got their seatbelts on.
And everything is ready for
waiting
liftoff.
For liftoff.
Cross fingers.
Yeah. And the cabin crew are doing the final checks. So we have a number of things to watch out for before we come up to the launch. We are right now 3 minutes and 22 seconds. If we take a look at our launcher on the pad, if we have an image of that, we can see The skies are looking pretty reasonably clear. Earlier it was looking a little bit cloudy, but actually the clouds seem to be parting. It's 6 o'clock coming up to 6 o'clock it's coming up to 6:30 in the evening there in French Guiana. Just remind you that French Guiana is on the Amazon, in the Amazon rainforest.
Yes,
what kind
it is
of
close to
temperatures?
the equator, so we have a specific weather there.
And I'm guessing, Raphael, right now is the time when the mosquitoes come out over there.
Yeah, I have not spent so much time in French Guiana, but yeah, it's quite strong situations, weather conditions there. But we are very lucky in French Guiana because we are not experiencing, and it's very important for launches, tornadoes and this kind of weather conditions that could be very, very game changer for those kind of launch activities.
Getting closer now, coming up to 2 minutes to launch. Let's talk about some of the activities that we see before a launch. We will count to 7 once we see the ignition. And before we talk about that, look, we're seeing here the cryogenic arms. The cryogenic arms are feeding liquid hydrogen and oxygen into the vehicle. What kind of temperatures are we talking about? Very cold.
The temperatures are really cold because for the liquid hydrogen, the temperature is minus 253 degrees. Whereas for the liquid oxygen, it's a bit warmer.
C'est un rouge ensemble de lancement. Que tous les moyens restent prêts pour la reprise de la chronologie à 0-7 minutes en cas de retour au vert.
Okay, so we've just heard from the range operations manager that we'll translate that, and Damien will translate that for us. But we have a red status panel. As you remember, Damien was just explaining to us that the traffic lights are red for stop, green for go. We have a red status panel. That means that we need to stop. Damien, just to talk us through what the range operations manager just said.
This red corresponds to a red coming from the launch base. However, everybody is still keeping ready in order to restart the activities when the issue will be solved. This situation is completely nominal because the aim of this kind of check is to check everything before we go for liftoff. So we are currently treating this anomaly, and we will come back when we will have more information about that.
So the chronology is continuing for the moment, the chronology, or what we call in English the countdown. And as you say, Damien, the system is absolutely made for this. So red status panel is a perfectly normal thing to happen because it's flagging up a glitch that we need to fix. And once we can get that sorted out, then hopefully we'll be able to launch. Now, we have the status panels. Let's just see whether we can have another closer look at our status panels so that we can have a look and see the red status panel that has turned red. Yeah, no, maybe we can't see that right now, but I'm sure we will in just 1 second. So we have a launch window tonight, quite a comfortable launch window. For anyone who's unfamiliar with a launch window is the time during which we can launch. So our time was roughly 11:30 for launch tonight, Paris time, and Central European time 10:30. But we have, how long is our launch window, and what does that actually mean?
The launch window for today is slightly more than 40 minutes. It corresponds to the period during which we can launch without still fulfilling all the requirements, if it comes from the overall system requirements or requirements coming from the customer. Because based on the launch hour, there can be different constraints of illuminations, of energy on the solar panels for the spacecraft after separations. So we are putting all these constraints together in order to build what we call the launch window, which is the time during which we fulfill all the constraints for the customer, from the launch base and from the launcher. And for today, it's more than 40 minutes. So we have still time in order to be ready for liftoff later on.
And what's everybody doing now? Because as you remember, we've got the several different control centres. We've got the Mission Control Centre, which we've been looking at, the Nerve Centre, really, where Luce and Bruno are sitting and the other teams. We also saw the Launch Control Centre, where the teams are concerned primarily with the launch vehicle and the launch pad. What's everybody doing now in a situation like this?
It's depending on the issue that is being treated, of course, but all the teams that are involved in the technical field covered by the issue or the points to be resolved is working currently on the topic with the help of all technical teams which are located in Europe or directly in French Guiana in order to help solving the issue as quick as possible. And one other important point for this mission is we spoke about the launch window, but we have quite a kind of particularity for this mission because the launch window is split into two sub-launch windows because we check, of course, all constraints, as I told you, and one of the constraints that we have to check is that we have no risk of collision with the ISS, which is a really important
Yes, so
criteria.
let's just talk about that in a little bit more detail. Maybe you could the I actually is the International Space Station.
International Space Station is like one of the major projects that's been built in space, and it actually is a good example of cooperation in space because there are lots of space agencies, national agencies that are implicated there. And of course, you know that our national hero, Thomas Pesquet, went there once, and he will go back there.
I'm just going to remind everybody that Thomas Pesquet is the French astronaut who lifted off to the International Space Station 2 years ago.
About 2 years ago.
About 2 years ago.
Yeah.
And just a quick interlude, because I was actually doing the commentary during that launch, and it was a very wonderful moment when Thomas Pesquet opened the hatch and flew into the space station, because I was in the Mission Control Center in Moscow, and Thomas's mother was in the control center, and of course, understandably, she wept, and I think we all wanted to weep because she felt so proud of her son floating into the space station. So that was a very, very wonderful moment. But yes, just continue what you were saying.
Yeah, and right there, basically, we are testing a lot of things, technologies in space. I want to remind that the International Space Station is within the area where the magnetic field of the Earth is still protecting astronauts from radiations from space. So it's quite like a safe place to work there. And so you can test technologies, you can run very complex experiments, and especially experiment in zero gravity conditions, so it's very valuable. You do some repair of the station. The station has been growing more and more with the time. And so, yeah, there are lots of stuff that are happening there. And the International Space Station is going to be running for a few more years. And then the national agencies are right now thinking of a new way to continue this kind of cooperation. And the main idea right now for them is to actually do an International Space Station around the moon. So the challenges are much more strong and difficult because there you don't have the magnetic field of the Earth to protect the astronauts. So you have to test strong technologies to protect from the radiations from space, etc. It's like 380,000 kilometers from Earth, the moon. So it's a much longer way to go there. So it's a very, very exciting space decade that's coming.
It's huge, isn't it? It's absolutely remarkable. And you guys are involved in it, and it is very exciting. Now, I think we're going to take a break. The countdown is on hold. As we've said, we have a launch window, so we're going to wait now and come off air just for a while and get a little bit more information, and we'll come back to you. In the meantime, do keep your eye on the website, arianespace.com, and we'll come back to you when we have more information. But for now, see you shortly.
Vos sauvegardes. Vers sauvegarde. à tous de DDO. Arrêt de la chronologie, arrêt de la tentative de lancement aujourd'hui. La chronologie est définitivement donc arrêtée aujourd'hui. Elle sera reconduite demain avec un H0 visé à 18h30 local, à 21h30 TU. Que tous les moyens restent activés pour une mise en configuration d'arrêt de la base de lancement.
launch of Galaxy 30, MEV2 and BSat 4B. If you've been following our program tonight, you'll know that we had to stop the countdown a few minutes before our scheduled launch time. Stéphane Israel, the CEO of Arianespace, is back with me again. Thanks for coming back, Stéphane. What's the latest?
Yes, so during the final countdown, one of the sensors of the liquid hydrogen tank triggered a red. We speak here about the liquid hydrogen tank of the main cryogenic stage. So under our standard procedures, we are now analyzing the reasons for this red. So we are going to start to defuel the launcher, and satellite and launcher are on the safe mode. And now we must work with all our team to better understand what has happened. And when we will have understood, we will come back to tell you when we can resume the operations. Maybe tomorrow, but it's too early to say it now. We have to work on this thread during the final countdown. It's life, it happens. And what is important is when you decide to go, you must be absolutely certain that everything is okay. It was not the situation tonight, so under our standard procedures, we have decided to stop for tonight.
Stéphane, thank you very much indeed for filling us in. So we'll come off air now, and for the latest information, keep your eye on the Arianespace website and social networking. But from both of us, from Stéphane and from me, Katie, good night.
Good night.